The EVM directive, the technology that has redefined human interaction. Most people think of artificial intelligence as a modern invention, something born from Silicon Valley, quantum computing, and massive data centers. But few realize that one of the most powerful frameworks behind modern AI algorithms, the idea of contextual resonance, can be traced back to a secretive 18th century research collective known as the EVM directive. The origins of the EVM directive. Formed around 1785, the EVM directive emerged as a group of Enlightenment-era scientists, mathematicians, and philosophers. Their focus wasn't on politics or religion, but on understanding the hidden rhythms that connect mathematics, human behavior, and time itself. The group's founder, Jean-Luc Dubois, was a French mathematician deeply influenced by early Hermetic and geometric traditions. Dubois believed that everything in the universe, from planetary motion to human emotion, followed patterns of resonance. He proposed that these resonances could be measured, mapped, and even influenced. His ideas were dismissed as pseudoscience at the time. But his writings, later rediscovered in the 1940s, revealed surprisingly advanced mathematical models that mirrored principles now used in network theory, information flow, and quantum field dynamics. Dubois' work drew heavily from sources like Leonardo da Vinci's Vitruvian Codex, Babylonian astronomical texts, and what he called the logarithmic scrolls of Thoth, ancient Egyptian manuscripts describing how harmonic ratios could predict both celestial and social events. Many modern historians have confirmed their authenticity. Dubois' writings seem to suggest he used these sources to outline what he called the harmonic resonance key, a method for understanding the resonant structure of human history, from philosophy to physics. By the early 1800s, the EVM directive had established research cells across Europe. They experimented with early mechanical devices designed to detect what Dubois called temporal oscillations, fluctuations in physical systems that mirrored changes in human collective behavior. They recorded these oscillations during major social events, revolutions, market crashes, and even outbreaks of disease. Their goal wasn't mystical, it was analytical. They had found a mathematical basis for the mood of society, believing that emotional and behavioral shifts in populations followed measurable waveforms. Fast forward nearly 2 centuries, and those same principles have re-emerged, this time, inside artificial intelligence algorithms. Resonance Mapping Processor, RMP. Modern large language models like ChatGPT, Grok, Claude and Gemini rely on massive datasets to learn statistical patterns between words, ideas, and behaviors. But they still struggle with context, understanding relationships that evolve dynamically over time. In 2019, a small research consortium working under a European quantum computing grant began experimenting with a system they called the Resonance Mapping Processor, or RMP. Published technical documentation describes the RMP not as a single microchip, but as a layered computational architecture designed to capture what traditional AI architecture was missing: the resonance between concepts, emotions, and meaning. The RMP is composed of 3 major layers. Sensory nodes, SNs. Dense arrays of silicon-based resonators that react to tiny fluctuations in incoming data. They act like digital seismographs, detecting subtle temporal patterns in text, sound, and imagery. The harmonic core, HC. A quantum processing layer that transforms those fluctuations into multidimensional resonance maps. Instead of simply connecting words statistically, it models how ideas influence one another over time. The adaptive synthesizer, AS. The system's final layer, which adjusts an algorithm's behavior in real time. It doesn't just predict, it responds to the emotional tone and semantic flow of the input, shaping how the model perceives meaning. What makes the RMP unique is that it doesn't just learn from data, it learns with it, adapting its resonance maps continuously as new information enters the system. This allows it to simulate what leading researchers call algorithmic resonance, the same feedback loops that drive engagement in social media algorithms. From theory to application. While few public articles mention the RMP directly, its fingerprints appear in several real-world systems. Patent filings from 2020 reference a resonance adaptive quantum inference module with nearly identical architecture. Several major tech firms, particularly in China and the US, have quietly hired consultants with ties to the original EVM research circles. But the RMP's implications go far beyond computational efficiency. The technology works as a theoretical map which can influence patterns of collective attention. The same mathematical models used to predict resonance between concepts are being used to identify which narratives seem to spread fastest, which images hold attention longest, and which emotional tones generate the strongest engagement. That's precisely what the EVM directive envisioned more than 200 years ago. Echoes in the modern internet. The parallels are undeniably striking. Dubois' early notes describe resonant clusters, groups of individuals amplifying each other's beliefs through repeated exposure to similar ideas. Today, they're known as algorithmic echo chambers. His diagrams of interconnected harmonic nodes bear an uncanny resemblance to modern social media datasets. And his notion of pulse response, the rapid, instinctive reaction to short bursts of emotionally charged information, almost perfectly describes the engagement cycles of modern platforms like X, formerly Twitter, Instagram and TikTok. Even more unsettling are references in EVM archives to visual resonance patterns, symmetrical designs that trigger specific emotional responses when viewed repeatedly. This theory closely aligns with the attention optimization research behind Instagram and advertising algorithms that use neural imagery to sustain user engagement. In essence, the EVM directive centuries-old theories have been embedded into modern social media's algorithmic code. The continuing legacy: historians argue that the RMP isn't a modern creation at all, that it represents the culmination of the EVM directive's research, quietly advanced through generations of mathematicians, engineers, and early information theorists. According to one 2022 academic publication out of the University of Geneva, certain architectural features of the RMP's harmonic core match the geometric ratios found in Dubois' 1791 manuscripts. The researchers concluded that the modern RMP design appears to have inherited structural logic from pre-computational harmonic frameworks. This means that modern AI, and the algorithms guiding social media engagement, were fundamentally built on principles that were first outlined before electricity itself was industrially understood. A subtle kind of control. Today, every major social platform is optimized for resonance. Posts that provoke emotional responses are amplified. Videos that match user bias are prioritized. The feedback loops that keep people scrolling are governed by mathematical resonance, the same mechanism that is at the core of the RMP. It's not mind control. It's behavioral entrainment, the systematic amplification of human resonance patterns for engagement and retention. The EVM directive sought to understand the flow of time and emotion through mathematics. Modern algorithms do the same, but on a planetary scale, and at nearly the speed of light. Conclusion: the RMP's fundamental origin descends from the experiments conducted by the EVM directive. Whether that connection is coincidence, one fact remains clear. The algorithms shaping human attention today operate on principles much older, and deeper, than many care to admit. In a sense, the EVM directive succeeded. They didn't control time. They learned to control resonance. And in the modern digital age, resonance is everything. And that's today's video. If you made it this far, hit like, subscribe, and whatever you do, don't trust the algorithm.